Welcome back. My name is Eitan Suez, Technical Marketing Manager at Solo.io. In this lesson, we cover Gateway API basics hands-on. So if you recall, in the previous lesson, we began our journey by installing an implementation of the Gateway API. We installed the kgateway open source project, of course. And in this lesson, we finally get to demonstrate basic usage of the API through a concrete example. And so what we're going to do is sort of outlined in this slide, but let's take a quick look at, again, the front page of the Gateway API portal. And if we sort of orient ourselves to what we did last time, we were playing the role of the infrastructure provider, installing an implementation of the Gateway API. Now we step down, and we're going to sort of look at the roles of the cluster operator and the application developer. We're going to create a gateway and an HTTP route. And then more specifically, when we configure a gateway, we're going to sort of observe this on-demand provisioning of the gateway infrastructure, something we talked about in the first lesson, and also inspect the status section of the gateway resource, which is very useful and important to know about. And then we'll turn our attention to configuring a route as if we were a member of an application team that needs a route for their API or application. And then we're finally going to verify that everything is functioning as expected. So with that in mind, why don't we step into our environment, another lab, and this time when we start the lab, you will notice that if we look, for example, at our namespaces or our gateway classes, that kgateway is already installed. And so we've got the Gateway API sort of in place, and we're sort of ready to start playing with it. And our first step will be to deploy some backend workload. Now in this lab, you'll see that I've chosen HTTP bin, which is a very common, popular sort of sample application or API, you might say. You can check out HTTP bin if you're not familiar with it at httpbin.org and familiarize yourself with the different types of diagnostic endpoints that it exposes. That's a useful thing to do. And so we're going to just apply a bit of YAML, which will deploy HTTP bin, a service and a deployment and a service account. And we can verify, maybe through this kubectl wait command, that our pod is ready. We can also look at our pods and check visually that the HTTP bin pod is running. All right, next step is to create a gateway. And so let's look at our first sort of example of a gateway resource. Let's kind of output it here on the screen. We see a resource of kind gateway that I've chosen to name my gateway. And the important thing here is the gateway class name has to match the gateway class that corresponds to the implementation of kgateway. And then finally, there's a listeners section, and there could be one or more listeners. And in this case, you see this sort of lone listener listening on port 80 for HTTP protocol. So this is probably the simplest possible gateway we could probably begin with, which was my intent. And so we apply our gateway. The next command, the kubectl wait command, is a rather interesting one, which shows the power of the status section in Kubernetes resources. And so to explain that, we can actually look at the gateway resource in YAML, in full YAML, and there's a few things we'll notice here. Of course, there's a little bit more information than what we specified. You can see here the resource ID and so on. But besides the spec, below the spec is the status section with a collection of information that pertain to the status of our gateway, namely the IP address that is associated with the gateway. So that would be typically the external IP address of the load balancing service that routes requests to the gateway. And a list of conditions. And you can see here that accepted is true and programmed is true. That means essentially that the gateway is ready. Notice, recall from our last lesson that we talked about how a gateway is actually provisioned as a side effect of actually applying this resource. We'll look at that in just a minute. And then finally at the bottom we see here information about the status of listeners, the fact that the listener has no routes attached. And that's an interesting observation. All right, so if we do indeed look at our pods and services and deployments, you'll see that there is a new gateway deployment by the name of my gateway with a load balancer service with the same name with an external IP address. And of course the pod for the gateway, which is running Envoy. All right, so we've got a gateway. Of course, that's half the battle, because the gateway, although it listens on port 80, it does not know how to route requests, and that's what routes are for. And so let's look at our first route. This is an HTTP route named HTTP bin. I guess it's apt. And there are three important sections to the spec here that are cited. The first one is called parent ref. And the parent ref is a reference to the parent, right? And in this case, it's the gateway we want to attach our routing rule to. If you can think about how this would work in a scenario where there may be multiple gateways, and here we're targeting a very specific gateway. Next is the host name, and that's kind of a matching rule. That means that if requests for a particular host name come in through this gateway, only then do we wish to sort of proceed and apply the routing rules. And the lone routing rule here is to route that request to the backend called HTTP bin, which is our service, right? The service HTTP bin happens to be listening on port 8000, and indeed it is. All right, so what do we do now? We need to apply this route, and then we, this is an interesting wait command. This is a command that sort of confirms that the route has been attached to the gateway. There's a couple of ways we can look at that. The first thing we could do is look at what this JSON path expression sort of is looking for. We can mimic that. If we look at the gateway, my gateway, in YAML, we'll notice in the status section that the number of attached routes on line 40 has jumped up to 1, and that's what we were checking for. We can also look at the status of the route, and we'll see in the status section for the route itself the fact that we have the fact that the route was accepted by its parent. That's a condition there on line 37. And so that's another way of sort of ascertaining the status of our route. And so all that remains is really to verify that we actually are routing requests for a particular host name. In this case, remember the host name was httpbin.example.com, will actually land on the HTTP bin workload that's running in our cluster. And so the first thing we do to test this is capture the gateway IP address, which is essentially the IP address of that load balancer service there for the gateway, and then submit a curl request. Now, what we would normally do in this in a normal situation is we would set up a DNS entry for that IP address and associate it with the host name in question. Presumably we own that domain name or what have you. In this case, since we're in a sandbox environment, I'm sort of going to leverage a capability of curl. Now, we could have just put a host header in the request. That would have worked as well. I tend to prefer this. We make a request to httpbin.example.com. I pick a particular endpoint called /headers, but I tell curl to resolve that host name to the gateway IP address when calls are made over port 80. And so when we submit this request, here we get a response. This is essentially what this endpoint does is HTTP bin looks at the request headers that it received and sort of echoes them back to you in a JSON format. So you see here the host header was httpbin.example.com. And that sort of concludes the demonstration. So let us then go back to our presentation and sort of wrap up. So the sort of the main lessons we can extract from this sort of exploration is maybe first the role-based nature of the API or the model. We had a gateway and a route. Those were separate, and the gateway owners are typically operators, and the route creators are typically development teams. We saw the on-demand provisioning of infrastructure, which makes that problem really trivial. We can have either shared or dedicated gateways, whatever combination we choose to have that's appropriate for our environment. And in terms of what we learned about the model, that gateways have listeners, that routes attach to gateways, and that's where we define our routing rules. And in the subsequent lessons, we'll explore more closely this notion that gateway owners have control over which routes are allowed to attach to it. So we didn't really talk about that in this section. So that concludes the lesson. In the next lesson, we are going to build on this example and answer the question, how do we expand this example to configure HTTPS routes? And of course, that involves creating certificates and terminating TLS and so on. And so I look forward to going through that lesson with you next. Thank you.